Good day, students. I hope everybody is doing great. Today, our main strand is geometry and measurement. Our substrand here is measurement. We are going to determine the volume of boxes by finding how many cubes of sizes each container is in centimeters and meters. So under the measurement, we are going to talk about the volume, how to determine the volume of a box by finding how many cubes of sizes each container is in both centimeters and meters. These lessons have been taken from the new curriculum of Pixis 5, strand number 3, substrand 3, content standard 2, and indicator 2. When you talk about the volume is the amount of space that a container has. The volume of a container or 3D shape is measured in centimeters cube or meter cube. So when you talk about the volume, we said the volume is the amount of space that a container has. The volume of a container or 3D shape. When you talk about a 3D shape, a shape with three-dimensional figure. So the 3D shape, which is also measured, the volume is measured in cubes. It's either in centimeters cubes or meters cube. Good. Method for calculating the volume of a container or 3D shapes. We have two methods that we can use to calculate the volume of what? A container or 3D shapes. The first one is the counting cube method. The counting cubes method, and then the formula. Counting cubes method is the use of cubes to occupy the space of 3D shapes. Each cube represents 1 centimeter cube or 1 meter cube, which shows the number of cubes that can occupy a particular space of 3D shapes. Then the total cubes of 3D shape is the volume. So when you talk about a counting cubes method, it's either you draw a cube and then you make several words, keys of a particular shapes, and then you count them or use the formula. So the counting keys method is the use of keys to occupy the space of a container or 3D shapes. Each cube represents 1 centimeter cube or 1 meter cube, which shows the number of keys that can occupy a particular space of a container or 3D shapes. The total keys of 3D shape is the volume. How to make keys of a 3D shape? Divide the length, the width, and the height of the container by their dimension, or you divide the length, the width, and the height of 3D shape by their given dimensions. Now, steps needed to calculate the volume of a container or 3D shape. The steps here. 1. Identify the unit of the dimensions. you make sure that all the measuring units are in the same what? Unit. Okay. So the length, the width, and the height must be in the same unit. If they are using the centimeters, you make sure all the dimensions of what? The 3D shapes or a particular shape are in the same unit. Make sure the SI units are the same. So after you identify the what, the dimensions, then you make sure the SI unit or the measuring unit for each dimensions are the same. If they are using meters, all the dimension must be the same. If not, then you do the conversion to make sure the dimensions are in the equivalent or they are the same unit or measuring units. Mathematically, when you talk about the volume is equal to the length of a shape or the 3D shape. When you talk about a 3D shape, a shape with the length, width, and the height. So in mathematical way of calculating the volume is equal to the length times the width times the height. So you multiply the length of the particular shape against the width and then against the height. First, you identify the measuring unit first. If they are all in the same measuring unit, then you can proceed multiplying them. If they are not, then you change to a particular measuring unit that you want. It's either they are all being centimeters or meters before you multiply the length of the shape against the width of the shape and the height of the shape. Let's solve one or two examples under the volume. Example, find the volume of the solid shape below. Sorry. Find the volume of the solid shape below. Now, we have this shape here, and they ask you to find the volume of the shape below here. So what we said about the method that we can use to find the volume, we are two here. Using the counting keys method to count the number of keys that occupies here, and that is the volume. Or using the formula, which is equal to the number of length or the dimension of the length multiplied by the dimension of the width against the height. And that one will also be the volume. So you are going to solve the two simultaneously, and then we get our answers here. So you first use the counting keys method by counting the number of keys that occupies what? The spaces here. Because we said the volume is the amount of space that a container or a box has. So let's count the number of keys that has what occupies the spaces that you have here, and that will be the volume. Good. So let me write my solution first. So under the counting, So under the counting keys method, which means you are going to count the number of keys here. Okay, so the first thing you have to do is what? You identify a key here. So let me identify a key here. Now this is how one key looks like. Okay, good. So this is how a key looks like here. So now you are going to count the number of keys that has occupied the spaces that we have. So the first one, you have the front layer, and then the second and the third layer here. Okay, so this is the first layer, the second, and then the third. So you first count the front layer. It's made up of how many keys? So looking at the front layers here, the number of keys that occupies here is 1, 2, 3, 4, 5, 6, 7, 8. So with the front layer, we have the 8 keys. We have the 8 keys here. So the front layer here, we have the 8 keys. So let's assume that a keep here is measured in centimeters. So we have the 8 keys, which is 8 keys here, 8 centimeters keys here. And then the second layer is also 8. Okay, once the front layer is 8, then the second layer is also 8 here. It's also made up of 8 centimeters cubes here. And then the third layer here is also 8. It's also made up of 8. 8 centimeters key. When I'm done, then I'll make my keeps. Okay, good. Now we have the 3 layers, and each layer is made up of 8 keys. So you just add or you just multiply 8 by 3, or you add 8 plus 8 plus 8. Okay, so it's either you add or you multiply the 8 by 3 here. So when you add them, let me write my keys well. So good. The keys right now. Keys. Good. So it's either you add them, okay, You add this, and then is this. Then you add this and that. Okay. So when you add the 8, you add the 8 centimeters cube plus another 8 centimeters cubes plus 8 centimeters cube. So 8 plus 8, that is 16, 16 plus 8, that is 24. So 24 centimeters cube for all. Okay. It's 24 centimeters cube here. Now, let me do my cubes for good. So the answer here is 24 cubes. So all these cubes here, when you count them, they are 24 because the front layers here is made up of 8 centimeters cubes, and then the second layer is also the same as 8 centimeters cube. So the 8 times 3 will give you 24, or you add all the 8 cubes. So the 8 plus 8 plus 8, and that will be the 24. Under the counting keys method, you count the number of keys over there. And then you can also use this formula. So to use the formula, to you quote the formula for finding the area, and then so under so you write under the formula. Volume volume is equal to length times width times height. Now you could see clearly that the dimensions have not been given, but we can use the division of the length and the division of the width and then the division of the height to multiply to get the total cubes here. So let's identify the length first. So let's use the longest part here to be the length, and then the other side here to be what? The width, and here will be the height. The height, we normally use the perpendicular lines here. So we have the 3 heights here, 1, 2, 1, 2, and 3. The length too, we have 1, 2, and then the 3. So you count the division of the length here. The length here, it has been divided into 1, 2, 3, 4. So the length is 4. Then you write the length, which is 4, okay? So the length has been divided into 4 centimeters. Good. Then you come to the what? The width. The width here, it has also been divided into 1, 2, 3. So the width is also 3 centimeters, which is 3 centimeters. Now let's with the height. Now looking at the height here, the height, this line here is the height, and the height, it has been divided into 2, 1, 2. Okay, good. And the height is also divided into 2 centimeters. Now, once we are able to identify the length, the size of the length, the size of the width, and then the size of what? The height, then we can also substitute into the formula, and then let's do it here. Now we have the length to be 4 centimeters. So the volume is also equal to the length, which is the 4 centimeters times, let me copy this one, okay? Times the weight, which is also the 3 centimeters that has been divided into 3, and then multiply by the height, which is also 2 centimeters, okay? Then when you multiply the 4 by 3, that is 12, and 12 times 2 is 24. And we have the final answer to be 24 centimeters. And don't forget about the measuring unit of what? The volume. The volume is always measured in what? In keys. So you put your small keys. You put your keys here. That is the keys. Now, our final answer here is that is 24. When you are using the volume, you check the division side of the length, the division side of what? The width, and then the height, and then you multiply them. So the 4 times 3, 12 times 2 will give you 24. Okay, so it's advisable to use the two methods at the same time to double check whether what you have done here is an accurate way. Okay, then let's solve the other example. The question says, find the volume if the length of the shape is 5 centimeters, the width is 4 centimeters, and height is 6 centimeters. Okay, so you should find the volume of a shape if the length of the shape is 5 centimeters, the width is 4 centimeters, and height is 6 centimeters. Good. So let's solve this one. You write your solution. You write your solution here. Good. And then you're going to find the volume of a shape. So let's identify the shape first, and then we label the parts here, okay, before you can use the formula to solve. So now we have the height, Good. And then going to draw a cube, the bigger cube, so that we can use it to good. Now, when you finish drawing the shape, and then you identify the what, the length. Let's use the side to be the length here. Now, per the question, the length is 5, which is 5 centimeters. And let's use this side to be the width, okay? And the width here is 4 centimeters. The height is 6 centimeters. Now, before you state the formula, since the length is 5, which means that the length must be divided into 5 groups. So you don't waste time here. You divide the length into 5. So you have your lines to divide the length into 5. Now you have the 1, 2, 3. So you have finished dividing the length into 5 here. 1, 2, 3, 4, 5. And don't forget about this line 2 is the length. This line 2 is also the length. So you need to extend the lines to divide this one into 5. So you have this one, then you divide it. You extend all the lines that you use to divide the length to divide the other length here. Okay. Let me extend this one to this one a bit. So that I can also extend this one to this one. The length will be okay. Good. Now we have done dividing the length into 5. The weight too. And when you talk about the weight, this is the weight here. You must also divide this line. The same weight is here and the last weight is here. So you must also divide this line into 4 equal parts. And then you need to do that. So you have your weight into 4 equal parts. Now you have this one. Then you have this one. Good. So this line too has been divided into 4. 1, 2, 3, 4. So you must also extend this line to also divide the other side here so that all the width will be divided equally. Now, extend this one to this side, same width, and you extend this one to this side. And you extend. Now you have done with the width here. The width here, all the width here has been also been divided into 4 equal parts. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Then the height too must also be divided into 6 equal parts. So the height, so must also divide the height into 6 equal parts here. And now you're going to divide the height into 6 equal parts. Now you have this side. So I have my 1, I have my 2 here, I have my 3, 4, and then the last one, that is 5. So let's check whether the height has been equally divided, because I wasn't using any measurement, so you can also accept any diagram that will also come to this video. Okay, so any diagram that is displaying here is what is not drawn to scale, so you must also accept that one too. Now we are not using a technical tools to also check every damage, but let's accept this one. So let's see the height here. 1, this is the line that we call it the height, another height, and another height is here. So let's see whether it has been divided into 6. So here is 1, 2, 3, 4, 5, 6. The height has been already been divided into 6. So let's proceed to divide the others height here. Now you extend this one to this side. Okay. And then you extend this one to this side. And then you extend this one to this side too. You extend this one to this side. Now you have done. Okay. So with this, you are going to identify one key so that when you're using the counting keys, it will be very easy for you to do it. So here, let me identify one keys here. And that is one key. Good. So that is one key. So this one is one key here. Now, when they ask you to count, we have how many layers? One layer here, the front layer is here, the second, the third, and the fourth. So let's count the number of keys that's made up of the first layer here. So the number of keys here, we have the 1, 2, 3, 4, 5, 6. And then 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So the first layer here is made up of 30. The next layer here is also 30, 30, 30. So the 30 times 4, we have the 4 layers, 1, 2, 3, 4. 30 times 4 is 120 keys, okay? 120 centimeters keys. Good. So when you are using the counting keys method, this is how the method is supposed to be. So we have the 30 times 4, and that is 120 centimeters cube. Okay, so when you're using the counting keys method, okay, now let me do my keys here. So that is 120 120 centimeters cube. Then that we can use the formula to also find or verify our answer here. So when you do the double check, it's very good to know what you're doing. So let's also use the formula to find this one. So here, under the formula, the volume is equal to the length of the shape times the width of the shape here. So we have this one. Now with this, we said the length of the shape is 5 centimeters, which is 5 centimeters here, times the width of the shape, which is 4 centimeters, times the height of the shape, which is 6 centimeters. Therefore, 5 times 4 is 20, and then 20 times 6 is also 120. So we have the 120 centimeters cube. Okay, and that is the formula. Let me do my small cubes. Okay. Good. So the final answer is 120 keys packed here. So the number of keys that have been packed here is 120. Okay, so you first identify one key. That is how the one key looks like. So when you pack, so the same thing have been packed 120 in counting. When you count them, they are 120 here. So that is a pack of what? 120 keys that has been occupied the spaces here. Okay, I think let's solve the last example concern about how to find the other lengths whereby the volume is given to you, and they also to find the length or the width or the height. Good. Now calculate the what? The height of the shape, which means the height here is omitted. Let me use, which means the height is omitted from the diagram that has been estimated. So here, calculate the height of the shape if the volume is 360. Wow. If the volume is 360 key, not square. Okay. Let me do the small 360 key. Okay, good. Now, if the volume has been given to us at 360 centimeters cube, the length is 12 centimeters, and the width here is what? 6 centimeters. So you first draw the shape, then let's write our solution here. Sorry. So you write your solution. Sorry. Solution. Good. Then you draw the shape. You draw the shape. This shape is too big. Let me reduce it. Okay. Good. Now you first label the shapes here. Let us assume here is the length. And per the question, the length is what? 12. Okay, 12 centimeters. And here the width here is 6 centimeters, which is 6 centimeters. Good. And the height is not given. Okay, so you can put any letter, K centimeters. Okay, good, to represent the height. The volume has been given to us as 360 centimeters cube. Okay, good. 360 centimeters cube. Now we are going to find the height of the shape. So let's use the formula. Then you state your formula here. So we always know that the volume of a shape here is length of the shape multiplied by the width times the height. Now, the volume has been given to us as 360 centimeters cube, which is equal to the length of the shape is 12 centimeters times the weight is 6 centimeters multiplied by the height, which is not known, and then we have used a letter to represent that, and that one is K centimeters. Okay, we use letter K to represent that. So let's say this one is K centimeters. Okay, good. Now let's do away with the centimeters here, K's, and then deal with the proper equations, which means we have 360 is equal to 12 times 6 times K. Okay. Then the other side of the equation, you multiply the numbers. You multiply the numbers first. So we have the 360 here, which is equal to 12 times 6, and that one is 72. That is 72 times the K. Then we still have the 360, which is equal to 72 times K. Anytime you multiply a number and the letter, you get alpha numeric, so it will be 72K. So this one is 72K. Good. So when you reach here, you divide both sides because you wanted to find the K, not 72K. You divide both sides by the number attached to the K, and the number attached to the K here. Let me do mine. Shift this one to this side. Okay, good. So the number attached to the K here. So first of all, let me do my small keys here before I will proceed. So here was 360 centimeters K. It's very necessary. Then, because we want to find the K is attached by 72. So you must eradicate this 72 from that place by dividing both sides so that the 72 will cancel the 72 and the K will be free. So let's divide both sides here. Divide this side. Divide both sides, okay, by the number attached to the K, and that number is 72. So we divide both sides here by 72. Here is 72. And here is 72. So when you divide both sides by 72, then this 72 will cancel this 72. Okay. Now K is free now. Okay. So now we have the K, which is equal to the K, which is equal to 360 over 72. Okay. So the 360 over 72 So we can do the cancellation here. So you first cancel, you can use any common multiple to cancel, but I think when you start with the minimum common multiple, it will be advisable that you'll be able to cancel everything here. So because the last digit end with 0 here, the last digit end with the even number, it means the two can cancel the two at the same time. So 2 goes into 360 is 180. Okay, good. And 2 goes into 72, and that one too is 36. Good. Now we have 180 against 36. So we have 36 here. Good. So the 360, it has reduced by 2 by 180 to 180, and then 72 has also reduced by 2 to say 36. Now you choose another common multiplier to cancel the two 180. I think you can also use 2 to also cancel the 180, and then you get what, 90, and then the 36 you cancel with the 2, and then you get 18. So here use so here you cancel 2 goes here, 90, okay, and 2 goes here, 18. Okay, good. Now we still have 90 over 18. Okay, I think we can still use 2 to cancel the 90. So 2 goes into 90. I think we have the 45, and the 2 goes into 18, and we have 9. Now we still have the 45 here against the what? The 9. Good. Write the 9 wall. Good. Now with this, I think 9, we can use 9 to cancel this one. 9 goes here, 1. 9 goes into 45, 5. Okay. Now we have 5 over 1. And any number divided by 1 is the same as that number. So therefore, K is equal to 5 centimeters, which is the same as the height. So now the height is equal to what? 5 centimeters. The height is 5 centimeters. Okay. Think we have done. So when you finish and you want to verify and check whether what you have done here is correct, then you substitute the 5 into the equation and then you solve. So the 12 times 6 times 5 will give you 360. So 72 times 5 will also, let's do small workings here. 72 times 5. Let us know you want to confirm it here. So you have the 72. I'm using different color here. So we have the 72 times 5. because 72 times k, and k is now 5. So you can put 5 here to multiply the 72. 5 2, 5 2 give us what 10. So you put 0. You put 0 here. Remember 1. 5 7 is 35 plus 1, 36. Okay. And that is 360. Okay. So you still get a 360 centimeters cube. I think that is the end of the lesson. That's the volume. So always try and use both method, the counting cubes method, and then the formula which stated the volume is equal to length times the width times the height. See you later. Bye.